All right, let's dive in. Today, we're going to build something pretty incredible, an AI that doesn't just give you answers, but one that can actually look at its environment, reason about it, take action, and, this is the crucial part, learn from its own mistakes. So let's get into it.
It all boils down to this one big question. Can we actually create an AI that learns to think for itself? Not just one that's following a really complex script, but one that genuinely adapts and gets better over time? Let's see how it's done.
So the goal here isn't just another chatbot. Nope, we're aiming for what's called an agent AI. The key difference is that an agent doesn't just talk back, it takes autonomous action. It's this combination of smart reasoning and adaptive learning that lets it actually do things out in the world.
To build our agent, we need a team of two. You can think of it like this. On one side, you've got the advisor. That's GPT-4. It's the genius. It's read the whole internet, and it can suggest a really smart move. And then you have the learner. This is our reinforcement learning model. It's a bit more cautious, because it learns from trial and error, figuring out what actually works by getting positive or negative feedback.
Okay, so before we throw our brand new AI into the deep end, we're going to start it off in a simple, controlled little world. Think of it like a basic task manager app. There are just a few clear tasks and a very limited set of actions it can take. It's kind of like the perfect little playground for our agent to learn how to walk.
So how does this thing actually think? It's basically a constant loop. First, it gets a task, something like organize emails. Then our GPT-4 advisor suggests what to do. But here's the key, our RL learner gets to make the final decision. After it acts, the environment gives it a reward, +1 for a good job, -1 for a bad one. And then, the most important step of all, the learner takes that feedback and updates its own strategy. It's literally learning from experience, one step at a time. And you might be asking, how does it know if it did a good job? Well, at this stage, it's super simple. The world has a clear rulebook. If the task is organize emails and our agent chooses mark done, boom, it gets a point. But if it does anything else, it loses a point. This kind of immediate, clear feedback is exactly how our learner starts to build its understanding of right and wrong.
And guess what? It works. In this simple, totally predictable world where the same tasks pop up again and again, our agent eventually masters its job. It gets it right every single time. But, and this is a huge but, what happens when we take the training wheels off and move it into the messy, unpredictable real world? And that real world is an email inbox. Yeah. Unlike our neat little task manager, an inbox is just chaos. Every single email is unique. There are no simple, repeating tasks. This is where our first draft agent is about to hit a massive brick wall.
And this exposes the agent's fatal flaw. It didn't actually understand what organize emails meant. It just memorized that exact sequence of words and connected it to the action mark done. That strategy is completely and utterly useless when every single email is a brand new sentence it has never ever seen before.
I mean, this slide just says it all, doesn't it? Our agent was trained on a simple command, organize emails. But the real world hits it with something like urgent, final feedback required on the Q4 marketing proposal draft EOD. The agent's little memorization trick just completely falls apart. It has no idea how to connect what it learned to this new complex reality. Okay, to solve this, we need our first major upgrade. We have to give our agent the ability to generalize, to understand that two totally different sentences can actually be about the same thing. And to do that, we're going to bring in a classic tool from the data science toolkit, TF-IDF.
So what the heck is TF-IDF? Don't worry, it sounds way more complicated than it is. In simple terms, it's a clever way to turn a piece of text, like an email, into a list of numbers, what we call a vector. This vector captures the essence of the text, highlighting the most important words. And the magic here is that we can now use math to compare these vectors and see how similar two different emails really are.
And here's why that is an absolute game changer. Look at these two emails. They're worded differently, but they mean the same thing. Our old agent would see them as two completely separate unknown problems. But by turning them into TF-ID vectors, our new agent can see that their numerical fingerprints are almost identical. It can now generalize its knowledge from one to the other. That's a huge leap.
So our agent can generalize now. That's awesome. But we can make it even smarter. For our final upgrade, we're going to give it a memory. We're going to use a powerful technique called Retrieval Augmented Generation, or just RAG. This is what's going to let our agent look back at its own past experiences to make better decisions right now.
So check out this new supercharged thought process. When a new email arrives, the system doesn't just look at it in isolation. First, it uses TF-IDF to instantly find the most similar emails it's ever dealt with in the past. Then, and this is the cool part, it bundles that new email and these old examples together and hands the whole package to GPT-4. With all that extra context, GPT-4 can now make a much, much smarter suggestion.
And this right here is the proof that our agent is actually learning. This is the aha moment. In episode 7, an email about client feedback comes in. GPT-4 actually gets it wrong and suggests flagging it. But our RL learner, based on its own hard-won experience, knows better. It overrides the suggestion, chooses to reply, and gets a +1 reward for it. It's not just a puppet anymore. It's learning when to trust its own gut.
This quote from the source material just sums it up perfectly. The agent is constantly tweaking its own internal strategy, its policy based on the rewards it gets. It's learning to use GPT-4 as a brilliant advisor, but not as a dictator. It's that partnership that makes the whole system so powerful. So, we've gone on quite a journey. We've built 3 different versions of our AI, each one a big step up from the last. Now it's time to put them all side by side and see just how much of a difference our upgrades really made.
This table really tells the whole story of our agent's evolution. We started with this simple agent, which just memorized raw text. It was fragile, brittle. Then we moved up to the TF-IDF agent, which could finally generalize by turning emails into vectors. And then, the final form, our full Agentic AI, which uses those vectors and RAG to give GPT-4 the past context it needs for some seriously good reasoning.
And if you're a visual person, this chart just says it all. The simple agent's performance, that first bar, it's all over the place. Low, unstable rewards. Adding TF-ID, the second bar, makes it way more consistent. But look at that third bar. Adding RAG and GPT-4 gives us the highest, most stable, and fastest learning agent by a long shot. That is the power of putting all these pieces together.
So let's bring this all home. What's the big takeaway? The crucial point is that by combining these 3 key pieces, a reasoner like GPT-4, a learner using reinforcement learning, and a memory using RAG, we successfully built an AI agent that can act on its own and actually get better over time, even in a messy, complex environment.
You know, we started all this by asking if an AI could learn to think for itself. And it seems the answer is, yeah, it's getting there. We've built a system that can perceive, reason, act, and learn. Which leaves us with a final and, honestly, a much bigger question. Now that these agents are possible, what important tasks are we going to trust them with next?